Hi, this is Dr. Richards with another video today on resistivity. I'll start with a brief discussion of what resistivity actually is before going over the defining equation. So, resistivity is a property of a material which measures how strongly it resists the flow of electric current. Now this sounds a lot like another quantity you've heard of, electrical resistance. But the difference is that it takes into account the dimensions of the material. I think this is best demonstrated with an example. Say we have a copper wire and an iron wire. We think of copper as having a lower resistance compared to iron, and in most cases this might be fair. But imagine we extend the length of this hypothetical copper wire. Its resistance will increase. The longer the wire, the greater the resistance. The resistance is in fact directly proportional to the length of the wire. At some stage, if we keep increasing the length of this copper wire, the resistance will be greater than the iron wire. It's not always going to be true to say then that copper has a lower resistance than iron. To compare copper and iron properly, we need to compare resistivity. The resistivity takes into account the length of the wire, but also the cross-sectional area. If we make the wire thicker, that is, if we increase the cross-sectional area, the resistance decreases. So taken together, the resistance is proportional to the length of the wire and inversely proportional to the cross-sectional area. We can write these two equations down together. Also, instead of writing in the proportional sign, we can write in a constant ρ, which symbolises the resistivity. This equation is the defining equation for resistivity. It's a measure of resistance which is independent of the specific dimensions of the wire. The resistivity is a constant for a given material. Just to compare a few values, copper has a resistivity of 1.7 times 10 to the minus 8 ohm meters, and iron is 9.7 times 10 to the minus 8 ohm meters. Beware here, the unit is the ohm meter, not ohms per meter. An insulator like wood or sulfur, on the other hand, would have a resistivity on the order of 10 to the 15 ohm meters. There are also some materials in the middle of this range called the semiconductors, and these will be the topic in a future video. However, I'm going to leave it there for today. If you've enjoyed this video, please let me know in the comments. Until next time.